Have you ever stopped to think how, well, just the simple act of eating is basically the engine room for everything you are, everything you do?
It really is fundamental.
Welcome to the deep dive. We're the ones who sift through all the information so you don't have to. And today, wow, we are plunging into your sources on vitamins and nutrition.
Mm-hmm.
Think of this as like your express route to understanding this really crucial subject without getting totally bogged down.
And what's compelling, I think, right from the start,
Yeah.
is just the sheer breadth we're going to cover today. It's huge.
Right.
We'll go from the absolute fundamentals,
Yeah.
the building blocks of what we eat, how our bodies use them,
Okay.
all the way to how these things influence our minds, our cultures throughout history, and even like a peek at how AI might completely reshape our diets in the future.
Exactly. So our mission here is to pull out the most important, maybe the most surprising insights from everything you've shared with us,
Right.
tailored for you for getting that deep understanding, but, efficiently.
Let's do it.
Okay, let's unpack this, starting right at the core. When we talk about vitamins and nutrition, what are we actually talking about?
Well, at the most basic level, right, we're talking about the essential stuff that keeps our bodies ticking over properly.
Okay.
So this includes vitamins. Those are organic compounds we need, but only in tiny amounts for vital things like growth, metabolism.
Mm-hmm.
Then you've got minerals, inorganic elements, also totally critical for health. And we can sort of split those into macro minerals.
Right, calcium.
Exactly. Calcium, potassium, things we need more of. And then trace elements, iron, iodine needed in much, much smaller quantities.
So vitamins and minerals, those are the micronutrients, and the macronutrients are the big guys, the main fuel.
Precisely. Macronutrients, that's your carbohydrates, your proteins, and your fats. They make up the bulk of our diet.
Right.
They're our primary energy sources
Yeah.
and also the raw materials for building and repairing tissues.
Okay.
But here's the key thing.
Mm-hmm.
While micronutrients don't give us much energy, like in terms of calories,
Mm-hmm.
they're absolutely vital, indispensable, really, for the metabolic processes that actually convert those macros into usable energy.
Yeah.
And for tons of other cellular functions, too.
So they're like the spark plugs or the oil in the engine.
That's a great analogy. Yeah, ignition keys, lubricants. They make the engine run smoothly, even though the macros are the fuel itself.
Got it. Tiny amounts, huge impact. Now, with vitamins specifically, there's this division, right? Based on how they dissolve.
Yes, exactly. We categorize them by solubility,
Yeah.
either fat-soluble or water-soluble.
Okay.
The fat-soluble ones are A, D, E, and K. And these can actually be stored in the body, in the liver, in fatty tissues.
Which sounds useful.
It probably was, evolutionarily speaking, build up reserves for lean times.
Right.
But the flip side, in our, often well-fed world, is that you could potentially consume too much. Storage means potential for toxicity if you really overdo it.
Oh, okay. And the water-soluble ones.
Those are the B-complex vitamins and vitamin C. Generally, they aren't stored in significant amounts.
So what happens to them?
Any excess is usually just flushed out by the body, mostly in urine,
Okay.
which generally means we need to replenish them more regularly. You can't really store them up for a rainy day in the same way.
Okay, that makes sense. Reserves versus like regular top-ups. Now, I saw RDA and DV mentioned a lot in the sources. What are those about?
Yeah, those are basically reference points. They help guide how much of each nutrient we should aim for daily.
Right.
RDA is the recommended dietary allowance. It's the average daily intake level that's estimated to meet the needs of nearly everyone, like 97, 98% of healthy people in a particular life stage and gender group.
Okay, pretty specific then.
Yeah. And DV, daily value, that's what you see on food labels, on supplement labels too. It gives you a percentage of a nutrient in one serving, usually based on a standard 2,000-calorie diet. So the DV is more of a general benchmark for the population, helping you compare foods.
Gotcha. And what about dietary supplements? They're everywhere.
They are. Supplements are products meant to, supplement the diet. They can contain vitamins, minerals, herbs, amino acids, all sorts of things.
But there's a key difference in how they're regulated, isn't there?
Yes, and this is really important for you to know. Unlike drugs, supplements don't go through the same rigorous pre-market testing for safety and effectiveness.
Wow. Okay, that's definitely something to keep in mind. Huge difference.
It is. The responsibility is more on the manufacturer to ensure safety, and the FDA steps in more after a product is on the market if issues arise.
Right. Now, the source material also brings up how AI, artificial intelligence, might look at all this nutrition stuff. That sounds potentially revolutionary.
It really does. What's so innovative is how AI could move beyond our traditional ways of just classifying nutrients.
How so?
Well, by crunching just massive amounts of data, biochemical properties of food, food composition, how different people respond biologically, AI algorithms can start pinpointing new bioactive compounds we didn't even know were important. And it can uncover really complex interactions between nutrients. You know, how one might boost or block another's absorption or function. Things that are just too complex for us to spot easily with traditional methods.
Like hidden synergies in food.
Exactly.
Yeah.
Imagine AI revealing that eating, say, these two specific vegetables together unlocks some unexpected health benefit because of how their compounds interact.
So AI sees connections that are kind of invisible to us.
Pretty much. And it can also dive deep into the food structure, what scientists call the food matrix, to predict how easily our bodies can actually get at and use the nutrients inside. That's bioavailability.
Okay.
And this all suggests that our current idea of what's essential versus non-essential might become much more personalized.
What do you mean?
Well, AI might identify someone whose genetics or maybe their gut microbiome means their body doesn't make enough of something we currently consider non-essential. For that person, it becomes conditionally essential. They need to get it from their diet for optimal health.
Wow. Okay. That's a completely different way of thinking about it. Personalized needs down to that level.
It's a potential paradigm shift, yeah.
So let's get down to the nuts and bolts then. The actual physical nature of these nutrients. What are they, chemically speaking?
Right. We're talking about their unique molecular structures. Carbohydrates are basically chains of sugar molecules.
Simple sugars, complex carbs.
Exactly. From single units, monosaccharides like glucose, to pairs, disaccharides like sucrose, to long chains, polysaccharides like starch, which we digest, and fiber like cellulose, which we don't.
Okay. And proteins.
Proteins are built from amino acids, strung together like beads. Some amino acids are essential because our bodies can't make them. We have to get them from food.
And fats, lipids.
Lipids, yeah.
Well,
It's a diverse group, includes triglycerides, what we usually mean by fat, phospholipids, important for cell membranes, and cholesterol. And then you have saturated versus unsaturated fats based on their chemical bonds.
And vitamins have unique structures too.
Oh, absolutely. Specific, often quite intricate chemical structures. Think complex rings in thiamine or the, well, relatively simpler structure of vitamin C. Each structure dictates its function.
And how do these structures relate to energy? Calories.
Well, the macronutrients, carbs, proteins, fats, their chemical bonds stored energy. When our body breaks those bonds through metabolism, that energy is released. That's what we measure in calories.
Okay, they're the fuel.
Right. Micronutrients, on the other hand, like many B vitamins, often act as coenzymes.
Coenzymes.
Think of them as helper molecules. They bind to an enzyme and help it do its job, often a job in those very energy-releasing pathways.
Ah, so they don't provide the calories themselves, but they're essential for the process of getting the calories out.
Exactly. They're crucial for the machinery that burns the fuel efficiently.
Okay, makes sense. The fuel and the essential helpers. Now, bring AI back in here. How does it help us understand this physical, chemical side better?
AI's got these incredible visualization tools. It can create super detailed 3D models of these nutrient molecules.
Like molecular blueprints.
Way better than blueprints. More than just static pictures, AI can use computational methods to predict how these molecules will actually interact with other things in the body, like enzymes or cell receptors.
So simulating how they work.
Exactly. It can simulate their behavior within complex biological systems, so we get a much more dynamic, functional understanding of how they operate at a molecular level. It's like watching the tiny machine in action, not just seeing the design.
Wow. Like a super-powered molecular microscope and simulator.
That's a good way to put it. And its power extends to processing the insane amounts of nutritional data we can collect now.
What kind of data?
Everything. Detailed food diaries, the precise nutrient breakdown of foods, your complete genetic code, your metabolic profile, what's in your blood, your gut microbiome makeup, physiological measurements from wearables. AI takes all this biological input.
And what can it do with all that data? What kind of insights does it generate?
Some really remarkable stuff. It can massively improve dietary assessment. Imagine an app using image recognition. You snap a photo of your meal, it tells you the nutrient breakdown.
That would be easier than logging everything.
Definitely. It can also predict how different individuals will respond to specific foods or diets based on their unique biology.
Personalized predictions.
Yeah. And develop highly personalized nutrition plans tailored to your specific needs and goals. Plus, it can help flag people who might be at higher risk for nutrition-related diseases, maybe even before symptoms appear.
It really sounds like AI is pushing us to think about nutrition in a much broader way.
It absolutely is. Under AI's influence, our understanding is expanding. It's not just about isolated nutrients anymore.
Right.
It includes those complex interactions within the food matrix itself and how that whole package interacts with your unique biology. It's driving towards a much more holistic, interconnected view, the whole food and the whole person.
And what could that mean for, say, public health guidelines down the road, like the RDAs?
Well, it points towards a future where we might move away from those broad, one-size-fits-all recommendations towards highly individualized, dynamic recommendations, driven by AI, constantly updated based on your data. This has huge implications for public health messages, for food production. Even regulations might need to adapt to cater to these personalized profiles.
That's incredibly forward-looking. Okay, let's step back a bit. Let's talk history. How did humans even start thinking about nutrition as, a thing?
Well, our relationship with food is obviously as old as we are. Archaeology suggests early human diets were actually pretty varied, often largely plant-based, depending on where people lived and what they could hunt or gather.
So not just the stereotypical caveman gnawing on a mammoth leg.
Not necessarily, no. More diverse than that popular image suggests.
And you'd assume people started noticing connections, right? Eat this, feel better, eat that, get sick, especially trying to live longer or cure things.
Absolutely. You see hints of this intuitive understanding really early on.
Yeah.
Traditional medicine systems worldwide use specific foods therapeutically, like liver for night blindness, which we now know is rich in vitamin A, or garlic for infections, long before we knew why they worked.
That innate drive for well-being. And as humans evolved, lifestyles changed. So did diets.
Exactly. Bringing meat into the diet offered a more concentrated source of calories and certain nutrients. Then cooking. That was a massive turning point.
How so?
It increased digestibility, so we got more energy from the same food. It could detoxify some harmful compounds. Some researchers even link the advent of cooking to the growth of our larger brains and shrinking guts. A fascinating coevolution.
Cooking, a game changer for human evolution, literally. And then agriculture changed everything again.
Yes, the Neolithic Revolution. Stable food supply is crucial for civilization. But it also narrowed our diets. We became reliant on fewer staple crops. Right. And that reduction in diversity has been linked by some to the rise of certain diseases of civilization. And all through this, our senses, taste, smell were co-evolving too, guiding us towards nutritious foods and away from poisons.
So this long history of interacting with food, when did the actual science of nutrition begin?
Well, you had that intuitive knowledge for millennia. But the formal science is much younger. You could point to Hippocrates, maybe around 400 BC, let thy food be thy medicine.
Classic line.
But the real foundations were laid much later, 18th, 19th centuries. Dr. James Linn's experiment in 1747 was huge, showing citrus fruits cured scurvy. A proper controlled trial.
Ahead of its time.
Definitely. Then Lavoisier, around 1770, figured out the basics of metabolism: food plus oxygen equals energy.
Okay, so the groundwork. And the 20th century brought the vitamin era.
Exactly. Casimir Funk coined the term vitamin in 1912, vitalamine, he thought they were. Same year, McCollum and Davis isolated vitamin A.
And it wasn't quick, right? It's step by step.
Oh, very slow, iterative work. Usually it followed a pattern. Identify a disease, suggest a dietary link, test it in animal models, and then finally isolate the actual chemical responsible. Rigorous scientific method, peer review, absolutely essential.
It's amazing it took so long to pinpoint these vital substances. And how does AI help us understand this history now?
AI can be a really powerful tool for sifting through all that historical data archaeology, isotopes in ancient bones, historical texts describing diets. By applying complex algorithms, AI can help reconstruct past diets more accurately and model correlations between dietary shifts and health markers over time. It gives us a much more data-driven view of our nutritional past.
Like a super analyst reading the history books. Okay, let's move to what you called the biological imperative, how nutrition basically fuels and directs life itself.
Right. This is the absolute core. Nutrition provides the fuel and the instructions for all life processes, from inside our cells right up to our whole body functioning. We're talking about nutrient metabolism, that whole network of chemical reactions.
Which involves breaking things down and building things up. Catabolism and anabolism.
Exactly. Catabolism breaks complex molecules down, usually releasing energy like digesting food. Anabolism builds complex molecules up from simpler ones, which requires energy like making new proteins or repairing tissue.
And key pathways are things like glycolysis.
Yep, glycolysis breaks down glucose, beta oxidation breaks down fatty acids. The energy released is captured mainly as ATP adenosine triphosphate.
The energy currency.
The universal energy currency of the cell, yeah.
Yeah.
Produced through pathways like the citric acid cycle and the electron transport chain. Think of ATP as the charged battery cells use to power everything.
So it's all about managing this energy, which brings us to energy balance, calories in versus calories out.
Yes. The first law of thermodynamics holds energy in equals energy out, plus or minus changes in body stores. Energy intake from food versus energy expenditure.
Which includes resting metabolism.
Right. Your basal or resting metabolic rate, RMR, the energy to digest food, thermic effect of food, TEF, and the energy used in physical activity. EF.
But it's not just simple math, is it?
Oh, definitely not. Our bodies have incredibly complex control systems regulating appetite, satiety, even energy expenditure. If you drastically cut calories, your body might try to conserve energy by lowering metabolism, for instance. It fights back.
So our bodies are smarter than a simple calorie counter. And where do our genes fit into this metabolic picture? That's nutrigenomics and nutrigenetics.
Exactly. Nutrigenomics is about how nutrients influence our gene expression, how diet talks to our genes.
Okay.
Nutrigenetics is the flip side, how our genetic variations affect how we respond to nutrients, why some people handle certain fats better, or why, like you mentioned, some convert beta-carotene to vitamin A more efficiently than others. Lactose intolerance is another classic genetic example.
So our genes influence how we process food, and food influences how our genes work. It's a two-way street.
A very dynamic interplay, yes.
And this is the basis for precision nutrition, tailoring diets to individuals.
Precisely. Moving beyond generic advice to recommendations based on your unique biological profile, genes, metabolism, microbiome, the works. Recognizing that genetic predispositions interact constantly with what you eat.
And how is AI helping unravel this gene diet complexity?
AI is invaluable here. It can analyze the huge data sets from genomics, metabolomics, studying all the small molecules and other omics.
Looking for patterns.
Exactly. Finding subtle patterns and correlations that predict how you might respond to a certain diet or metabolize a specific nutrient. It can model complex metabolic pathways, simulate reactions, pinpoint those crucial gene-nutrient interactions linked to disease risk or intervention success.
It's like giving us X-ray vision into our own biology and how food interacts with it.
That's a good way to think about it. And AI is even helping broaden our concept of energy beyond just calories.
How so?
We can start looking at thermodynamic efficiency, how well we convert food to ATP. Even the informational energy of food molecules, how they act as signals to switch genes on or off. AI helps integrate these different dimensions for a much richer picture.
Truly fascinating. Okay, let's shift focus now to how our nutritional needs change over our lives. It's obviously not static, right? From baby to grandparent.
Absolutely not.
Yeah.
Needs are incredibly dynamic. They change with age, gender, development stage. Think about child development.
Yeah.
Good nutrition then is the bedrock for survival, physical growth, cognitive development, immune function, everything.
And the consequences of malnutrition are severe.
Devastating. Stunting impaired growth, often with irreversible cognitive effects. Wasting severe thinness from acute shortage, wrecking the immune system. Hidden hunger, micronutrient deficiencies impacting brain development. And now, increasingly, the burden of overweight and obesity in children too, setting them up for chronic disease later.
It impacts everything, even school performance.
Hugely. Concentration, cognitive ability, it's all linked.
Yep.
And then as we move into adulthood, gender differences become more pronounced.
Like iron needs for women.
Right. Higher iron needs for women of reproductive age due to menstruation, even higher during pregnancy. Postmenopause, women need more focus on calcium and vitamin D for bone health. Men generally need slightly more calories due to muscle mass, maybe a bit more zinc. Folate is critical for women who might become pregnant.
So distinct needs, often linked to hormones and body composition.
Yes, and these persist beyond just the reproductive years. Hormonal changes at other times, like menopause, also influence needs.
And then at the other end of the spectrum, older adults, what are the key nutritional considerations there?
Needs shift again. Often there's an increased need for protein to combat sarcopenia, that age-related muscle loss.
All right.
Vitamin B12 absorption can decrease, so that's important. Calcium and vitamin D remain vital for bones. Fiber for digestion, potassium for blood pressure. Hydration becomes critical too, as the sense of thirst can diminish.
And calorie needs usually go down.
Generally, yes, due to lower metabolic rate and often less activity. So nutrient density, getting lots of vitamins and minerals per calorie, becomes even more important.
And those blue zones, places with exceptional longevity, what do they tell us about diet and aging?
They offer interesting clues. While the specific foods vary, you see common patterns. Largely plant-based diets, moderate meat intake, healthy fats, often fermented foods, and crucially, caloric moderation. The Okinawan concept of hara hachibu, eat until you're 80% full.
So it's about the overall pattern, not some magic bullet superfood.
Exactly. Whole, minimally processed foods, eaten in moderation within a supportive community and active lifestyle. That seems to be the recurring theme.
And how might AI help us manage these changing needs across the whole lifespan?
AI has huge potential here. It can analyze all that individual data, age, gender, genetics, metabolic markers, activity, health status, to provide truly personalized dynamic advice.
Dynamic meaning it changes as we change.
Precisely. Imagine AI tracking a child's growth and tailoring meal plans, providing precise recommendations during pregnancy, helping manage weight or chronic disease in midlife, supporting nutrient density and specific needs in older age. It could monitor intake, provide real-time feedback, constantly adjust recommendations.
Like a lifelong personalized nutrition coach in your pocket.
Potentially, yes.
Okay, let's explore that mind-body connection more deeply. Nutrition's impact isn't just physical. It hits our brain, mood, cognition.
Oh, profoundly. The brain is incredibly nutrient-hungry. Specific nutrients are critical for its structure, its function, making neurotransmitters, regulating mood.
Like omega-3s.
Absolutely. Omega-3 fatty acids are key components of brain cell membranes, linked to cognition, mood. Deficiencies have even been associated with things like ADHD symptoms or aggression in some studies.
And B vitamins.
Crucial for energy metabolism in the brain and for synthesizing key neurotransmitters, serotonin, dopamine, norepinephrine. Deficiencies can manifest as depression, anxiety, cognitive decline.
Vitamin D, magnesium, zinc.
All vital. Vitamin D receptors are found throughout the brain. It's linked to mood, serotonin production, neuroprotection. Magnesium helps calm the nervous system, involved in neurotransmitter function. Zinc is important for regulation, neurogenesis. Deficiencies in these are often linked to mood and cognitive issues. Even just being dehydrated can zap your concentration and make you feel irritable.
So our brain chemistry is directly influenced by what we eat. And then there's the gut-brain axis. That connection seems increasingly important.
Hugely important. It's this constant two-way communication street between our gut and our brain. And the gut microbiome, those trillions of microbes living in our digestive tract, are major players.
How do they influence the brain?
They produce neurotransmitters themselves. They modulate inflammation throughout the body, which affects the brain. They influence how we react to stress. And what shapes the microbiome more than anything?
Diet.
Diet. Fiber feeds beneficial bacteria, prebiotics. Fermented foods can introduce beneficial microbes, probiotics. A healthy gut environment is increasingly linked to better mental health outcomes.
So feeding your gut well is feeding your brain well. Now, the sources also touched on something interesting: nutrition and more immediate emotions. Laughter, crying, anger. Is there a link there?
It's an intriguing area. On a basic level, yes, significant nutrient deficiencies can definitely lower your threshold for negative emotions. Think anger, that irritability from low blood sugar.
We've all been there.
Right. So poor nutrition can contribute to emotional instability, anxiety, irritability. But it's important not to confuse this with specific neurological conditions like pathological laughter and crying, PLC, or pseudobulbar effect, PBA.
Okay, what's the difference?
PLC-PBA is usually caused by damage to specific brain pathways controlling emotional expression. It's a neurological issue. While chronic malnutrition might worsen underlying vulnerabilities, it's not the primary cause of that kind of uncontrollable emotional outburst.
So nutrition affects our baseline mood regulation, our susceptibility, but maybe not these specific neurological phenomena directly.
Generally, yes. Although when we look at things like emotional eating or significant mood swings, there can absolutely be underlying nutritional factors, blood sugar crashes, micronutrient deficiencies making coping harder.
And could AI help us understand this diet-mood link better?
Potentially, yes. By analyzing large data sets, correlating dietary patterns, nutrient levels, maybe even microbiome data, with validated measures of mood and emotional well-being, AI can help uncover more subtle connections and perhaps identify individuals who might benefit from specific nutritional interventions for mood support.
Fascinating. It really emphasizes how interconnected body and mind are through what we eat. Now, let's shift again to the sociocultural side. Food isn't just fuel, it's culture, right?
Absolutely. It's deeply woven into the fabric of our societies, our identities, our social lives. What you eat often says a lot about who you are, your culture, your ethnicity, sometimes your social status or religious beliefs. Think about Thanksgiving turkey in the U.S. or specific foods for holidays around the world.
It's symbolic.
Hugely symbolic. And eating together commensality is fundamental for building social bonds, strengthening communities, passing down traditions. The social meaning often outweighs the pure nutrition, which is why dietary advice needs to be culturally sensitive. You can't just ignore these deep meanings.
Absolutely. Think about family recipes, community feasts, and then you have formal belief systems, religious dietary laws, traditional food philosophies.
Right. Many religions have specific rules. Kashrut in Judaism, halal in Islam, vegetarianism common in Hinduism and Buddhism, the idol diet and Rastafarianism. These aren't just rules, they carry deep spiritual significance.
And traditional medicine systems.
Like Ayurveda from India or traditional Chinese medicine, TCM, they have incredibly intricate dietary philosophies. Ayurveda focuses on balancing doshas through diet, considering tastes, digestive fire, Agni. TCM uses food as medicine to balance yin and yang, considering the energetic properties, hot-cold, of foods. Both emphasize individualization.
So these ancient systems had a very holistic, personalized view of food long before modern science.
In many ways, yes. Focused on balance and harmony with nature and the individual, which contrasts sharply sometimes with the global nutrition transition we're seeing.
What's that exactly?
It's this worldwide shift, often linked to urbanization and globalization, towards diets high in processed foods, sugar, unhealthy fats, animal products, and lower in fiber and micronutrients, the so-called Western diet, driven by economic development, the rise of industrial food systems, pervasive marketing, changing lifestyles,
And the consequences.
often a loss of traditional food diversity, an erosion of that older food wisdom, and unfortunately a rise in diet-related chronic diseases like obesity, diabetes, heart disease. There's a real tension between traditional approaches and the modern industrialized food system.
It feels like we might be losing something valuable. How can AI help navigate this complex sociocultural food landscape?
AI could play a few roles.
Sure.
It could analyze traditional diets to scientifically identify beneficial components. It might help personalize advice from systems like Ayurveda or TCM for modern life, using locally available foods. It could help people navigate different food cultures if they move or live in diverse societies. And on a bigger scale, AI could model food system dynamics to help policymakers create healthier systems that respect cultural contexts.
So recognizing food is culture, not just chemistry. Now let's get into the really personal side, the human condition and nutrition. Eating isn't always rational, is it? It's messy.
Definitely not rational much of the time. Our choices are a complex mix of biology, psychology, culture, emotion. We have innate drives for pleasure, learned habits, comfort eating when stressed or sad. There's often a huge gap between knowing what's healthy and actually doing it.
So how do we bridge that gap?
Well, approaches like intuitive eating and mindful eating try to address this. They encourage rejecting the diet mentality, those external rules, and reconnecting with your body's internal signals.
Like hunger and fullness cues.
Exactly. Honoring hunger, feeling fullness, finding satisfaction, coping with emotions without using food as the primary tool. Mindful eating focuses on paying full attention to the sensory experience of eating without judgment. Both aim to integrate instinct, emotion, and rational thought.
Learning to trust your body again, essentially. And then there's the ethical side of choice freedom versus responsibility.
Yeah, that's a tricky balance.
Mm-hmm.
How much is individual choice versus the influence of the environment, affordability, accessibility, marketing? Can we hold individuals solely responsible when healthy choices are much harder for some than others due to socioeconomic factors?
It's complex.
Public health wrestles with this. How much should society intervene? From just providing information to taxes on unhealthy foods to restrictions, especially for kids. It's an ethical tightrope.
A really tough one. And on a darker note, there's nutritional neglect.
Yes, a very serious issue, especially for children. It's not always intentional malice. It can stem from parental factors like ignorance, mental health issues, substance abuse, or just overwhelming poverty and lack of resources.
Yeah.
No access to affordable, healthy food, nowhere safe to cook.
And the impact on kids is devastating.
Profound and long-lasting. Physical health, cognitive development, learning ability, emotional regulation, behavior. It can cast a very long shadow. It's a critical public health concern.
A stark reminder of how fundamental nutrition is, which makes the paradox you mentioned, the paradox of cruelty, even more striking. How can intentional harm coexist with this life-sustaining need?
Acts of cruelty usually stem from much deeper psychological issues, extreme ideologies, trauma, sociopolitical forces, not directly from nutrition itself. While severe early life malnutrition can sometimes be linked to problems with impulse control or aggression, it doesn't explain organized violence or calculated cruelty. The roots are typically far more complex.
It's a different category of human behavior. And can AI help understand or address these complex behavioral aspects, eating disorders, neglect?
Potentially. AI could analyze patterns associated with disordered eating or identify risk factors for neglect by looking at aggregated, anonymized data if done with extreme ethical care and oversight.
That ethical part seems crucial.
Absolutely. AI could also power more accessible tools for information and support chatbots, personalized education. But again, these are deeply human problems requiring human compassion and ethical frameworks, not just tech solutions.
AI is a tool, not the whole answer. Okay, let's widen the lens again to the big picture. The ethical and AI revolutions transforming nutrition.
Right. As we understand more, and as AI gets more powerful, the ethical stakes get higher. We have to grapple with fundamental issues.
Right.
The right to food, it's a recognized human right, yet hunger and malnutrition persist. Socioeconomic disparities, the stark link between income, education, and diet quality, leading to health inequalities, and the massive influence of food marketing, especially targeting kids with unhealthy products.
Huge societal challenges. How can AI help promote more equity and ethics here?
AI offers possibilities, identifying vulnerable populations for targeted support, optimizing food supply chains to reduce waste and get nutritious food to underserved food deserts, providing low-cost, accessible nutrition information via AI tools, monitoring the food environment to support policy advocacy.
What the risks are there too?
Big time. We must avoid amplifying existing disparities. Biased algorithms, unequal access to technology, lack of digital literacy. These could make things worse. We need to prioritize fairness, privacy, transparency, and the needs of the most vulnerable. The goal has to shift from mere food security, enough calories, to nutritional security, access to diverse, nutrient-rich foods for optimal health for everyone. AI could help design systems for that, but only if guided by strong ethical principles.
So AI could be a powerful force for good, but requires extremely careful handling. Now let's really focus on AI as the architect of future nutrition. What does that mean in practice?
It means AI is set to fundamentally change how we approach nutrition thanks to its analytical power. We're already seeing it. Dietary assessment, those apps using computer vision to analyze meal photos, like MyFitnessPal has features, Snap Calorie, making tracking easier.
Okay.
Personalized nutrition using machine learning on your data to give tailored advice. Think services like Zoe, January AI, even simpler things like smoothie recipe generators adapting to your preferences. Disease prediction and management AI analyzing health records and dietary data to predict risk or help manage conditions like diabetes. Food science using AI with spectroscopy to check food quality or even design new products. Public health analyzing big data to track trends, map food insecurity, behavior change AI chatbots or coaches offering personalized support, and research modeling metabolism, finding new biomarkers.
So it's moving from generic advice to super personalized, predictive, dynamic care.
Exactly. Imagine AI telling you, based on your genetics and recent blood work, swap the spinach for kale this week for better iron absorption. That level of precision.
From the user's point of view, it sounds like it could make healthy living much simpler, less guesswork.
That's the potential. Effortless tracking, personalized plans that adapt, real-time feedback, simplifying healthy choices and contributing to well-being.
But those ethical considerations we touched on, they loom large here.
Absolutely critical.
Yeah.
Data bias will work equally well for everyone, regardless of ethnicity or background. Privacy and security, this is highly sensitive data. Transparency, can we understand why AI makes a certain recommendation? Explainable AI or XAI. Cultural sensitivity, avoiding biased or inappropriate advice. User autonomy, guiding, not manipulating. Accountability, who's responsible if the AI gets it wrong. And the digital divide, ensuring everyone can access and benefit, not just the tech-savvy or wealthy.
It's a minefield.
It requires incredibly careful governance, ethical frameworks, and a commitment to equity. We need to ensure AI helps close gaps, not widen them.
So if AI views nutrition as, say, complex biological inputs in a system.
Yes, high-dimensional inputs in the complex system of the human body. Its goal, programmed by us, is to model interactions, predict outcomes, optimize inputs for desired health outputs. It sees the purpose functionally, quantitatively, energy, building blocks, regulation, signaling, sustaining life, and optimizing its quality.
But it needs human oversight for the ethics, the context, the empathy.
Absolutely. It's about synergy. AI's analytical power, combined with human expertise, dietitians, doctors, researchers, policymakers, providing critical thinking, context, and ethical guidance.
Yeah.
AI augments us. It doesn't replace the human element.
Okay, this has been an incredibly rich and detailed deep dive. Pulling it all together, what's the big takeaway? The overarching purpose of vitamins and nutrition.
I think we've seen it's incredibly multifaceted.
Yeah.
Fundamentally, it's survival, yes. But beyond that, it's about enabling optimal function, physical, cognitive. It's about adaptation, reproduction, and ultimately, it's about quality of life, well-being, about thriving, not just surviving.
And that idea we started with is life itself, fundamentally about dealing with vitamins and nutrition.
From a biological standpoint, and even how AI models living systems, you could argue yes. The constant intake, processing, and utilization of nutrients is absolutely intrinsic to what defines life. Maintaining that complex organization against entropy requires this constant flow of matter and energy managed through nutrition.
So for everyone listening, what are the key practical things to take away from all this?
For you as an individual, maybe embrace lifelong learning about nutrition. Try practicing mindful or intuitive eating. Prioritize whole foods where possible, and maybe become a voice for healthier food options in your community.
And for society.
We need better food literacy for everyone, support for community programs, celebrating diverse food cultures, tackling those socioeconomic barriers to healthy eating head-on, integrating nutrition more fully into healthcare.
And policymakers.
Things like evidence-based marketing regulations, especially for kids, investing in public health nutrition, supporting research, policies ensuring equitable access to healthy food, and crucially, developing those robust ethical frameworks for AI in nutrition.
And finally, those deeper questions. How does AI and our modern understanding change how we view life, death, and nutrition?
AI can vividly model how nutrition impacts health spans and lifespans. It powerfully illustrates nutrition's role in the quality and duration of being alive, even if it doesn't touch the existential core of death itself.
And who's benefited most historically?
Generally, those with consistent access to diverse, nutrient-rich foods and the knowledge to use them well. The experiment of life, as you put it, shows that effective nutritional management is key to flourishing.
And belief versus intuition.
Early understanding was likely a mix. Modern understanding is scientific, but intuitive eating reminds us to listen to our bodies. AI might even model intuition as sophisticated pattern recognition. It's complex.
So it really comes down to this. The purpose of vitamins and nutrition isn't just keeping us alive, but optimizing the richness and flourishing of that life.
Exactly. And achieving that globally likely requires this careful partnership, harnessing AI's power while guiding it with human wisdom and ethics.
An incredible journey through the science, history, culture, and future of nutrition. Thank you so much for this deep dive.
My pleasure. It's a vital topic.
And for you listening, we hope this gives you food for thought. Maybe consider how these insights apply in your own life, and perhaps delve deeper into those crucial ethical questions around AI as it shapes our nutritional future.
This is DigitView.